Okay, good morning. We'll go ahead and get started. Thank you all for joining us this morning. Welcome to our webinar. Today is going to be Understanding Federation on HCS. So my name is Peter McCarron. I'm the Senior Product Marketing Manager here at HashiCorp, covering Consul. Joining me today is Cody. He's our Technical Product Marketing Manager. Just so you all know, this webinar is being recorded. We will be making the link available after post-processing. Usually takes us a few days to get it uploaded to the website, as well as having the slides and everything available. Throughout the entire presentation, feel free to drop your questions into the chat. We'll answer them throughout, but then also we'll make sure we save some time at the end to go through. So let's go ahead and dive into it, because I think this is a super exciting topic and something that we've talked about in the context of Consul, but not so much in our managed services. And this is something that some folks have asked us about. So here's what we're going to cover today. So we're going to give you an introduction to Federation. I think most of the folks who've joined this call maybe are familiar with it or have an idea, but just to give kind of a review as far as like what we mean when we talk about Federation when it comes to Consul. Give some examples about why it matters. Then Cody's going to walk us through a demo. And then, like I said, we'll be able to answer some questions for you all. So let's start with kind of introducing what Federation is. I think there is a common term that's often thrown around in the industry, but it has some kind of different meanings depending on the tool that you're talking about it in reference to. I think it'd be good for us to walk through what we mean when we talk about Consul's Federation specifically, and where it kind of comes into play. So here's what we want to think about is we have a Consul data center. Excuse me one sec. I'm going to try and reshare some different slides here. All right. Well, I apologize for the lines missing on here, but I'll carry on with my point. So basically, why do we need Federation? So let's say I have a single data center with Consul, and essentially Consul's aware of all these services. I have maybe my service mesh running. It's handling all TLS and directing all my traffic. And in general, my life is good. I'm very happy with what happened, what's going on here. Then a second data center appears. So essentially, let's assume that I have another cloud that's running somewhere, that I have another Consul instance. Maybe it's aware of all those services. It's handling the traffic. It's handling all their traffic. It's handling all the TLS. Life is also here good too. But really what the challenge is that these are two kind of very independently operating environments. They're not necessarily aware of each other, even though they may have some overlapping services that are working together. And so what I need to do is I need to figure out, like, how do I get these to work together in such a way that is going to be helpful for me. So if I'm trying to actually have this kind of cross data center communication, what do I want to do if I want to make sure that, if I have one service residing in data center one that wants to talk to data center two? One of the things that I could do is I could say, all right, well, I'm going to make it all just one giant cluster. So maybe what I'm just going to do is create it so that I have both Consul agents that are communicating together. They're aware of all the other services that are running. Maybe I expose all those services to each other. The challenge that this creates, and the reason that this isn't necessarily a good practice, is that it kind of creates these potential vulnerabilities. If I have every single service that is aware of every other service that is running, even if it doesn't necessarily ever need to actually talk to that other service, what could end up happening is that I could actually create another endpoint for a malicious actor to be able to get in. Because ultimately, if I have a service that gets recognized by Consul, that means that it becomes aware of everything else that's acting in the environment. So my other option is I could actually just federate them. And there's where we have this kind of communication piece. So what we're talking about specifically when we say federation is we're talking about what we call WAN federation over mesh gateways. So to back up a little bit, the way that Consul operates is that it has a gossip protocol. Essentially what is happening is that the agents are communicating with each other, letting them know within a cluster that, hey, these are the services that I have. These are the current IP addresses that I have. This is the information that I have that's available for our cluster. If I create just a larger cluster, all those agents have to participate in this gossip protocol to be able to receive that information. When we use WAN federation, what we can actually do is we can designate the server agents, so basically the leaders of each of those gossip protocols, and allow them to be able to say, you share the rest of the cluster's information with these other server agents, so that we can have an awareness of where things are, but we're not necessarily exposing the exact location of every single service to every single agent. This is great from a latency perspective, but it's also great just from a general security practice. And so the three use cases that we see when it comes to federation, when people say, why would I even want this, is this idea of you have cross-region deployments, which we'll talk a little bit about, application resiliency, as well as what we call progressive delivery, this idea of kind of tightening the coupling between the networking delivery process and the application delivery process. So let's talk about cross-region deployments. Let's see where my slide here is. Oh, wonderful. Give me one moment here. I apologize. We're going to try sharing this screen, and hopefully this will work. Okay. I hope that everyone is seeing my screen right now. I will continue with the track, but unfortunately, it looks like On24 is having some issues with my slideware. So cross-region deployments. If you've been in presentations with us previously, you've probably seen this slide. Essentially, what this is saying is that we have this cross-region kind of capability to where regardless of where you're running your workloads, whether they be in different clouds, whether they be a mix of on-premise, that console has this awareness of where everything is running. The thing that we don't talk about is just the idea that federation is a core component of this, because the idea is that even though I have these multiple regions or these multiple clouds that are running, I kind of want to treat them as independent environments. I don't necessarily want to make it all part of one large web and one large network, because there's going to be challenges that I run into that. Instead, what I'd like to do is be able to say to each one of these regions, each one of these data centers, go ahead and take care of the services that are running in there. Maybe there's some geographical reasons for that. Maybe I have some requirements as far as where I can localize data and I can't share that information across other regions. Maybe there's other regulatory compliance that I need to do, but I can still manage this all in a very consistent manner. And so the nice thing with the federation piece is that I can use Consul to apply my traffic policies and apply my security policies across the entire environment, because it's going to share all that information via the federation component, but it's going to allow each of these to be able to operate independently. And so that's really powerful, because you're really getting this benefit of agility, but truly having this kind of fully networked world. From an application resiliency standpoint, really what you're looking at is, let's say that I have a data center that's primarily in Azure, and I'm located my main applications in there. And so the way that people interact with my web front end, for instance, is by hitting that particular console data center. What I could do is I could have maybe I have some regional reasons that I can't use Azure in a different place, or maybe I have this need that I want to have a backup in a different cloud. So I could have another data center in AWS, another data center in GCP. So let's say that for whatever reason I'm experiencing an Azure outage, that there's something that goes down, maybe the region's not communicating correctly, maybe I have a bug or something that happened with my software that my users are no longer able to hit that. One of the nice things that I can do with Consul in this instance, and because I federated these together, is I can actually redirect that traffic to my other data centers. So theoretically, what I could do is I could have the same type of web front end that's actually running in AWS, that if I happen to experience an outage and Consul can no longer resolve the request, it'll be intelligent enough to actually route that over to my AWS instance, so that the user is none the wiser. I have this, they're getting the same experience. They're able to still be able to process their request, but I am kind of covering myself from a safety standpoint. Some of the things we've talked about in the past is like this idea of like, oh, if I had a database sitting in AWS and a front end sitting in Azure and an API sitting in GCP, and that's not really the architecture that we want to talk about. Really what we want to look at it more is like, all right, maybe I do this cross cloud or cross region, that I build in kind of these resilient versions of my application, so that in the event that something bad happens, I have this capability ready to go. So the progressive delivery standpoint, what we mean by that is, inherently the way that networking works, and this is one of the bottlenecks that we see, is that there's a networking challenge that comes with deploying a new application. CI/CD is great in the sense that it helps us move very, very quickly. We're able to do a lot in terms of like rolling out new versions of applications, testing them, being able to iterate really fast. But the challenge that you're going to have is I may have new code that's ready to go, but if I I deploy it into one of my environments, how do I make sure live traffic can actually hit that and I'm able to, sorry, it looks like my slides aren't moving. This is really, really frustrating. Okay. Yeah. I apologize, folks. I thought I was sharing my screen, but apparently I was not sharing my screen. This is, yeah, give me one moment. Okay. Yeah. This is the slide that I'm on, and I'm going to send the presentation out after this, just so everybody knows. Apologize for some of the formatting issues that we're having on these. But basically, what I'm trying to get at is that if I have an application that it goes through, that essentially what I could do is if I deploy a new version of my application in my environment, I could actually use Consul to essentially split the traffic. So what I will do is I could say like 90% of my requests that are coming in from users should still go to my primary data center. However, 10% can actually go to my test one. So if maybe I have this test environment that I have a Consul agent in, and this is where I roll out new versions of the application. This is super powerful because essentially I don't actually have to have them residing in the same area. I could have different data centers that are essentially like a whole testing ground to see like how things operate. And I could just very, very minimally tweak the traffic. And then eventually, if I wanted to change it over, I'd have that capability. So we're going to go ahead and move here. And my slides just do not want to cooperate with me today. This isn't fun. So what I'm going to do is I'm actually going to go ahead and turn it over to Cody because he's going to do the demo now and walk through kind of how his process. Again, I apologize. I'm going to send the slides out to everybody after this. Unfortunately, the platform's just not playing nice with my formatting today. So Cody, I'll turn it over to you.
Sounds good. Thanks, Peter. Give me 1 second. I'm going to fire up sharing on my side. Hopefully I have better luck than Peter on this side of the world. All right, I'm going to assume that everybody can see my screen and that it's sharing correctly. So what you'll see here, so real quick, rolling back, my name is Cody DeArklin. I'm a technical marketing manager for HashiCorp. I tend to talk a lot about how we deliver applications, how we lifescale applications. So I'm really excited for what we're doing from a federation standpoint inside of HCS, and excited to come and talk to you guys a little bit about it today. So what was off this little annoying message that's there? Cool. So what you'll see on my screen is my Azure account. This is the one that I use for testing this functionality and doing work inside of this environment. And what you'll see is that I have a couple of resources deployed down here. I have a Kubernetes cluster, and unfortunately, we can't do this. Typically, I like to do these as like live demos where we go and we build out everything as we go, and I step you through the process. Unfortunately, because of the time it takes to deploy, Kubernetes cluster, as well as the time it takes to deploy HCS, we would literally probably get through the deployment of each of those and not be able to do anything with it. So we're doing a little bit of the cooking show approach where this stuff is already built. So I've got 3 different HCS environments set up, DC1, DC2, and DC3. These were set up with Federation, and I'll show you a little bit about how we go through and set that up. It's actually a pretty slick process. And then I've got a Kubernetes cluster that's joined to each one of these. And what I like to talk about when I talk about this flow is this is what we kind of see from people who would be kind of implementing this team-driven approach of Kubernetes, where these teams own their kind of individual data centers and their applications are located within those application stacks. Now, this could be across different regions, right? So you'll see I have everything in US West 2. These could be spread out against different regions, and they could be sorted out in a number of different ways. The power of federation comes, so we'll click in on this Consul data center, and I'll hit the UI here. The power of federating an environment comes from the Consul environments being able to share the information between their control plane. So from an application standpoint, these applications think they live right alongside each other, but ultimately they actually can live really wherever, and the proxies are handling this communication between these systems. It makes it very easy to control the way you're flowing traffic between these data centers and apply policy that kind of controls how this communication happens. So in practical implementation, you'd think of this as, a team comes on board, they deploy out a Kubernetes cluster. They choose if they want to federate with an existing data center. So maybe they drop into US West 2 alongside me and they just want to jump into DC1 and federate to that environment, or they choose to bring their own kind of slice of the console pie where they get their own set of console servers and they federate into those, or they join their Kubernetes cluster into that console server and then federate it to the rest of the environment. So they get the same policies. They're able to communicate across the mesh. Those mesh gateways are able to allow communication between those environments. Let's jump into the command line real quick and let's take a look at a few bits of the configuration. So I'm going to zoom in a little bit here. Make sure that we're actually able to get some good view of the text. We have a pretty slick command line that will help us out with doing the actual configuration process. So we have this Azure HCS extension. So I hit enter intentionally so we could just see the different commands that are available. This is an extension of the Azure CLI. So it's just another module that bolts on and it opens up a number of configuration options. So just as a quick example, if I do Azure HCS, choose to generate my Helm values. So what I'll do is I'll do one that I did previously. So you can see the output. This immediately gives me the Helm configuration for joining that console cluster. All right, so I don't have to go through and kind of pull this information from a number of places. I don't have to download a configuration file and pick out the different configs that I need to actually use to join. I use this command, it dumps me out a config, and I can just run Helm on that. Similarly, if I do azhcs generate Kubernetes secret, let's clear this so we can get back and stop the screen. There we go. Get a very long set of text that's ultimately just a pre-formatted Kubernetes secret. So the process for actually joining a Kubernetes cluster to an HCS console instance is literally generate a token, apply that secret, generate the configuration secret, apply that secret, and then generate the Helm values and install Helm. And a lot of those can be piped into just a kube control apply, so it happens kind of on the fly. We're talking about 3 or 4 commands that get you to a place where you're joining this environment. As far as getting HCS itself deployed, there's a couple of different ways to do that. I tend to default kind of doing it in the command line, so I can do azhcs create. Figure out some of this in. I'm not going to run it because it would take me forever, but you can see, I give it a name, I give it a data center name, I choose what resource or group it goes into, I give it my information as far as my email address goes, tell it a CIDR block I want to go on. If I don't provide one here, it'll default to whatever the default is for HCS. Because this is a secondary instance, I feed it in a federation token that I generated with a different command, and I give it an external endpoint. I can use this to script out deploying out these environments. Another option that we have, I switch windows. There we go. We also actually released recently the early version of the HCS provider for Terraform. So if you go into the Terraform registry, you can see HashiCorp HCS. We have a number of guides in here for actually provisioning out different components of HCS via Terraform. So we can go in and create clusters. We can create a multi-node cluster and do the federation process. We can peer VNets. This one, personally for me, was kind of the most frustrating to kind of do manually, is kind of poke around and do the peering. But when you can actually provision out a cluster with Terraform and then grab those values and feed them in, it starts to show you how you can kind of chain this automation together and make a very scalable process for getting these environments up and running. So in my case, I used the Azure CLI. It was just an easier path for me at the time. So we have switch back into the UI. I didn't mean to switch over there. It's kind of in summary, we have 3 data centers joined in one federated cluster. I've got no applications deployed right now. These are sharing things like traffic policy. These are sharing ACL tokens. These are sharing intention configuration. So all of this stuff is replicated between the environment, and this is kind of where the power or the scale of federating an environment comes into play. You don't have to worry about individually and kind of artisanally crafting each one of these environments. They join the control cluster, and ultimately they get the policy pushed down. So it creates this avenue for delivering kind of this consistent policy between environments. this all can be managed via Terraform. So like I'll typically, when I do my traffic stuff, I'll do that in Terraform, have it wired up to Terraform Cloud, and have Terraform Cloud kind of run these applies to shape my traffic, or set up my backup services, set up my terminating gateways to integrate with other like Azure services. Let's get in and we'll start deploying out some services across this environment. Do this. Let me make sure I'm in the right directory. Cool, I am. So right out of the gate, I'm going to make sure that I'm in the right Kubernetes cluster. I'm in the DC1 kube cluster. Like any good magician, know that there's nothing in the environment yet, or at least I hope there's not. Cool. So I have Consul installed, and that's about it. So I'll go ahead and do the DC1 version of that. While that does its install, take a look at the actual config, and I'll kind of break down what's happening in this configuration. I've got a service account that's created. Since we have ACLs enabled and we have TLS enabled inside of the cluster, we need a service account in order to do communications, because when we deploy Consul this way, it's kind of secure out of the box in this configuration. So it needs a service account in order to make changes and interact with Kube. I do a deployment for my front-end service. I'm only doing one replica, which makes doing a deployment kind of silly, but it does give me the ability to scale it up if I see fit. I've got a couple of annotations here, and these are important. So I've got Consul connect inject set to true. This is basically enabling the service mesh capability. I don't always do this. A lot of times I'll set up like a namespace inside of Kube, and I'll apply this. I'll set that namespace to automatically inject the sidecar, so I don't have to worry about the annotation. I did it in this so I could talk through it, but that's what this is for. It's basically kind of on an individual service basis being able to turn it on. I set a metadata version. Now this comes in useful when I want to do like traffic splitting or traffic shaping, and I want to say, hey, send 50% of my traffic to V2 or 50% to V3. It's easier to apply this out of the gate. So I typically recommend that people set it like a metadata version on their app, like their whatever version they're deploying. That way they can control this later. You can apply it later. It's just a little bit easier to do it out of the gate. It gives important information, and I tell it what its upstream is going to be. And there's an important note in here. I've got this connect service upstreams, and I'm telling it to go to the API service on port 5000 in data center 2. So you saw when I was in the UI that I had 3 data centers set up. I'm going to put my API service in data center 2. So you scroll through, there's not much else that's interesting in here. Set up a service, give me a load balancer. So if I go in and I do this, see, I have my load balancer service here. Back over, we'll get this up. With any luck, it'll be up and running, but it'll be throwing unhappy errors on the bottom. So these will spin infinitely forever because there's no connectivity to that secondary data center. So let's get that going. So oops, that would have been bad. We'll switch over now to the secondary data center. We'll apply the data center 2 config. Make sure everything's going. Cool, it is running. So similarly, I'm not going to step through all of this because we talked about a bunch of it already. 2 service accounts, 1 for the API, 1 for the Redis. Wouldn't be a demo app if I didn't use Redis in some way. So I have my API service deploying. I'm doing 3 replicas for that, but so differently, or a little bit different in this case. I'm setting my upstreams to a database in DC3 and then the Redis server here in DC2. I was explicit here about DC2. I didn't actually need to put that there. It'll infer that it's local if I didn't include that, but I try to be consistent. Doing some bad security here and setting static values. Typically, I'd use like Vault to dynamically inject these. That's part of that zero trust security story that we talk a lot about, like the way that our products integrate with each other. We can very easily consume Vault secrets as part of this deployment. I just didn't have it set up in this case. So the rest of the stuff set up to deploy. Everything looks good. So we will double check that stuff deployed. That pod is still coming up. We switch back into the UI for a brief moment. There we go. So we can see the API connectivity came online. We still don't have database connectivity. It's pretty upset still. We go back in, we can look at DC1, we can see the front end services up and running. Take a look at routing, you can see that it's everything's resolving and set up correctly. Go down to DC2. We can see the API service and the Redis service are connected and up and running. If I come and take a look in here, let's go back. Take a look, everything is set up correctly. Hop in here, quick look at proxy. See, everything looks pretty healthy at this point. So now we will go and set up the third tier. Switch back over to the CLI. Back into DC3. This gives us our database instance, and if I switch back over fast enough in a few moments, we should see it pop up and actually connect successfully. This little watch so we can watch it come online. There we go, that's running. Switch back over, and there we go, connectivity is established. Now this is a little bit of a silly example. I tongue-in-cheek do this demo because I think that stretching your database across an entire environment is not always the smartest move. Probably better to use like Postgres replication or something like that, or use like the cloud native services in Azure or something along those lines. But what you can see here is that when you look at this through the lens of a developer building applications, I'm able to consume different components of this application across a number of distinct clusters inside of an Azure environment, right? So this application now lives in DC1, DC2, and DC3, and is ultimately acting as kind of the single application. From the application side, it thinks that everything is sitting right alongside it. So it's a little bit cleaner of a process for how these things communicate with each other. Ultimately, it's all available from a policy standpoint. I can set up routing and splitting between those. I could roll out a V2 of the API if I wanted to. I can switch that. I can switch it and set it as a backup so that if the primary went down, it automatically started using the API in DC3 instead. And these are all things like traffic splitters, traffic resolvers that we use in Consul pretty often. It also gets interesting when we start to bring in, you can see I have this Postgres database that's managed. I mentioned this a few moments ago. I could have that DC3 reference or deploy out a terminating gateway. I don't have it set up right now. And that terminating gateway can be used to integrate with existing services that don't have a proxy ability with them, like this Postgres database. That lets that Postgres database act as part of the mesh. And then I could have the DC2's API tier communicate with that Postgres database through DC3 if I wanted to, somewhat distributed architecture. So that's the high level of the demo. Unfortunately, because of the speed of taking things up to deploy, it would have taken too long to build it up from scratch. Peter and I are here to answer any questions and talk a little bit about federation. One last thing I'll mention, I meant to talk about earlier. When you go out and deploy HCS, you do need to make sure you're peering these environments together. So like, for example, if I go into, just as an example, I go into VNet 1 and I hit this peering option, we can see that I peered this out to the different components of the environment. So this AKS cluster is able to chat between other two AKS clusters, and that's because ultimately it's going to communicate over those mesh gateways, so they need to be able to reach each other. So I've set up peering to allow that communication back and forth. I've also peered it into the HCS environment, so it understands how to talk to HCS directly. What gets really interesting here, though, so you can see in this example, this is VNet 1, and I've got AKS 1 talking to HCS 1. If I switch over and go into VNet 2, where obviously the number 2 Kubernetes cluster lives, it's only able to talk to HCS2. So ultimately, these resources are all talking directly to their console server, and then the console servers, from a control plane standpoint, are talking to each other. And we can see that by going into our HCS deployment, hitting our managed resource group, hitting our VNet, and looking at peering here, and we can see that I'm peered between each of those other HCS clusters in the environment. So that was all set up, like these configurations here were all set up by the HCS CLI. They would also be set up via like the Terraform provider if you use that to go and deploy it as well. So I meant to mention that way earlier when I was doing the tour of the UI, but I forgot. So catching up on it now. Anyways, Peter and I are here to answer questions. So happy to stick around and answer anything you want to know about federation in a console environment.
Yeah, and just while we're waiting for some questions to come in, just so folks know, we do have a Learn Guide available to walk through some of the stuff that Cody mentioned. So if you do want to try out HCS Federation for yourself, don't have to wait for the demo kit or for the repo from Cody. We do have that available just on learn.hashicorp.com/console. It does have a beta tag. This is technically a beta feature for HCS. So if you are interested in it, also just keep in mind, we did it specifically for HCS because it's a question that we get up about being able to federate multiple AKS clusters. However, federation is available in versions of standard console as well. So if you're looking to do more of a cross-cloud deployment, you can absolutely do that. So Cody, one of the things that I think would be good maybe to talk about that we didn't really touch in is, I know for getting started with HCS, we have we have a couple different SKUs that are available, right? So what is, do you have to do a production cluster, or is this something that's available on a development cluster?
You can definitely do a development cluster. Just since we have a few moments here, what I'll do is I'll share back out my screen real quick, just to make things interesting. If I go in and I create a resource and I do HCS, the blinding speed of the interwebs. There we go. And I hop into the catalog item and I do create. I have this option here to go down to a development SKU and what you'll see is that actually shrinks it down to being a single node deployment. There's not a lot of differences between a single node and a multi-node. Obviously, you lose redundancy, you lose replication between multiple servers locally, but ultimately you can get the same functionality. So if you're looking to test this out, if you're like, hey, the stuff Cody did was pretty cool, I want to check out maybe doing traffic splitting. It's just multiple cube clusters and one HCS environment. You can do that with just a single node cluster and let that single node act as that control plane. So definitely the development cluster is a really cool feature. It's far cheaper. Peter's the money guy, so he can probably talk more to that side of things, but it's definitely far cheaper than running kind of the production ready 3-node SRE supported cluster. The development cluster is just a great way to get started and start consuming HCS in a quick way.
Yeah, I think the nice thing about it too is that it allows people to really try this out in their own environment versus having to fully commit. Understand that people are not necessarily ready to drop all their production workloads into a new tool. Let's see, waiting for some other questions to come here. So keep in mind that the Q&A box, just go ahead and drop some of the information. Again, this session was recorded. We'll make sure that we obviously send that out. As well as a cleaned up version of the slides that you'll be able to view at your leisure. Let's see. So while we're waiting on this, Cody, maybe want to talk a little bit about just some of the benefits of using HCS, where you can have you were using AKS clusters, but obviously HCS supports more than that. So maybe talk a little bit about kind of some of the native integrations that Azure supports right now or that we support for Azure with HCS.
Yeah, totally. So let's talk a little bit about kind of what I see as kind of some of the common journeys that people go on. I think when you start to consume cloud services, for better or worse, people tend to kind of default to how can I take the virtual machines I'm running on-prem and run them in the cloud? And that's, most of us know at this point that that's the most expensive way to move to cloud. But hey, it happens. And when you're used to a specific operating model and you want to consume in a consistent way, it totally makes sense. So people usually will bring those in as virtual machines first, and then look at how they can start to migrate off of that virtual machine into a Kubernetes cluster. Knowing that people are going to generally go that route, it makes a lot of sense for us to have Consul act as this kind of consistent control plane between systems that are very different. So in case virtual machines, while networking is always going to be networking, ultimately the way virtual machine networks is a little bit different in the way that we consume it from the networking in Kubernetes cluster. So we could have that virtual machine join Consul as well, be a node in the service mesh, be part of that policy-driven control. Sometimes I'll throw a front end on on a virtual machine and then do the rest of my like API tier and stuff like that in Kubernetes, right? So I can have that act that way. I can also set it up in the virtual machine knowing I want to migrate it to Kubernetes later and use the traffic policies to migrate that over. So Consul's very good at operating in kind of this multi-runtime, multi-platform service mesh space. You know, I talked a little bit about the terminating gateway examples like that. The virtual machine is kind of what traditional computing, traditional infrastructure. But on the flip side, like how do we take advantage of the native services that live inside of these environments? How do I use like Azure Functions? How do I use Azure Container Instance? How do I use things like things like Azure Managed Postgres? And these are all available via both like the terminating gateway that I talked about already, as well as the ingress gateway. The ingress gateway is kind of the opposite of a terminating gateway. If a terminating gateway lets you communicate outbound to systems that live outside of the mesh, ingress gateways give you a path to get into the mesh. And how do you actually give like a pathway into things that live in the mesh and have a logical place to apply traffic policies coming inbound? You know, for example, if you want to be able to do a V1, V2, V3 of your front end and kind of cycle between those, you can do that at the ingress gateway point. If you just deploy out a kube load balancer, you don't really have that option. You have to deploy out another load balancer and connect to that new IP address. Using the ingress gateway is kind of a more, dare I say, scalable architecture than just throwing load balancers out every day. So I hope that gives you a good answer to that question, Peter.
Yeah, absolutely. We did have another question come in, and it's interesting because I think it actually has two components to it that we can touch on. So the question is like asking about what's the easiest way to federate to an on-premise environment without Kubernetes. And I'm wondering if maybe we could touch on this in two things. So like federation as it applies to on-premise environments, and then also federation as it applies to non-Kubernetes environments.
Yeah, so, you know, just I know you mentioned not Kubernetes, but just to throw it out there, like the path to get this working in Kubernetes between like an on-prem kube cluster and an AKS cluster is super easy. Right now, the federation that we're showing in HCS doesn't support on-prem federation. It's being worked on. It's a very high visibility feature that we're working really hard on. It's not available now, but you can do this with like the traditional open source console. So open source console can very easily federate between that on-prem environment. If you do it in Kube, it's really easy, and it's like I mentioned earlier, it's 3 or 4 commands that still stands true to an on-prem environment. You have to make sure you have an external IP address though for your Kube cluster on-prem and stuff like that, but it's usually not that big of an issue. I do it in my home lab at home. I'll NAT inbound the federation port, and since it uses the mesh gateways, all that traffic goes through the mesh gateway. So really, it's just one port that needs to be opened up between my on-prem data center, soaking up power bill in my garage, and Azure upstairs. Now, thinking about it not in Kube, really the same thing applies. It's just on virtual machines instead. So we stand up Consul servers. We set up a server that's going to be the mesh gateway. If you're in a pinch and you want to just try it out, you could throw that mesh gateway on the Consul server itself and have that act as the mesh gateway also. Generally don't recommend that. That's not, I would say that's not for production use, but I've done it for like demos and to show off the functionality in a very simple way. So spin up a virtual machine. My recommendation, if you do this, use Packer to build out an Azure image. So you use HashiCorp Packer to go in and script out all of the install steps for bringing down Consul, getting it installed, setting up the mesh gateway. But once you have that mesh gateway up, you can federate inbound to an AKS cluster that's running in Azure. You can federate into a virtual machine. It doesn't matter. Either way, it operates the same at that point. That's kind of when we talk about the consistency of communication with Consul, that's what we're trying to drive here, because that's how you accelerate people's workflows. That's how you make them able to operate in a more agile way, is giving them a consistent way to do the same thing so that when they learn it once, they can use it many times.
Thanks, Cody. We had another question come in that I think is good. It's a not a federation question, but I think it's a good topic for us to talk on. So can you talk a little bit about how you get Postgres, like kind of platform as a service solutions or other managed solutions to interact with Consul Service Mesh? Like obviously we know that it works with other like IaaS type of VMs, but how do we make sure that things that can't have a sidecar proxy attached to them are able to participate in Mesh? Yeah,
so that's where that terminating gateway story comes in. So we deploy out let's keep it simple and let's use the Kubernetes example. I've got a kube cluster running. If I was still in the Azure portal, I could show you. If I have this kube cluster running, it's maybe in the data center 3. It's federated already. It's part of the mesh. But I have this Postgres database or Azure managed Postgres running as like a PaaS sitting alongside. I would update my Helm chart to include the terminating gateway configuration, which is three or four lines where it says enable terminating gateway, give it a load balancer IP. I would then apply a configuration file that creates an external service in Consul that says, hey, the Postgres database lives at this IP address. And what that does is it tells Consul, hey, there's a thing here. Here's how you get to it. I would then create a configuration entry for my terminating gateway that says, hey, you're in charge of this thing, right? The terminating gateway is how we get to this path. And what that tells the Consul control plane is, hey, when the mesh needs to communicate, when the data plane needs to make a connection to this database, this is where it goes to. It goes through the terminating gateway, and the terminating gateway hands it off. From an architecture standpoint, the idea behind the terminating gateway is to put it as close to that instance as possible. So if you've got a VNet set up in Azure, that's like specific, like where your PaaS services live, you should drop a terminating gateway there. Same thing applies to what I said with the mesh gateway a few minutes ago. If you're not using Kube, you could stand up a VM and put the terminating gateway on there and still have that join as a client to the service mesh. Once that's there, the service mesh doesn't really know the difference anymore. It says, hey, this is part of the mesh because it's going to go through the terminating gateway anyways. You will break SSL. By default, let me clarify that. By default, you will break SSL at the time of termination. So you'll carry that MTLS encryption all the way through to the terminating gateway. And when the terminating gateway makes that last mile connection to the Postgres database, that will by default be not MTLS traffic. Now I say but not by default because you can configure it. So if you grab the cert off of that Postgres database and you bring that into to the terminating gateway and reference it in the config, you can actually carry MTLS all the way through to that service if you wanted to. So it's very possible. I've seen it done many, many times. So with that pattern, you can actually consume pretty much any of the PaaS services that you want. It's not just limited to Postgres. I use that as an example because I like to hammer databases for fun in my spare time, but you can live your dream.
Yeah, that's a really good point. And like one of the things, part of what we're trying to get at when we talk about federation and we talk about Consul service mesh is this idea of having this ubiquitous data plane, as Cody mentioned, that everything is going to be able to connect to each other in some way or shape or form, even if it's not directly a part of the mesh. We're trying to make it as seamless as possible and not make this kind of big kind of amalgamation of servers. So, all right, see if we have any last minute questions coming in here. No, it looks like we have answered them all right now. Okay, if that's the case, can definitely give some folks time back in their day. As always, you can feel free to reach out to us. We're always happy to answer more questions. Again, just as a reminder, we'll be sending out a video of this recording. We'll be sending out the slides. They'll all be posted on our website. And I just want to thank everybody for taking the time to be with us today. And I hope you have a great day.
Thanks a lot, everyone. Have a good day.